Welcome to the GESDA Summit interview series. With us, Professor Jaimie Henderson, Professor of Neurosurgery at Stanford University School of Medicine. You're one of the world's foremost experts on the application of image-guided surgical techniques for placing, for example, deep brain simulators for movement disorders. Also with us, Professor Mu-ming Poo, Director of the Institute of Neuroscience at the Chinese Academy of Sciences. You focus on the use of non-human primates as animal models to study higher cognitive functions and human brain disorders. And you both participated in a session called Neuroaugmentation, Hype or Hope. So, Professor Henderson, hype or hope?
I think it's a little bit of both. It's important to, I think, modulate the hype and build up the hope. And I think what we heard during the session is that there are advancements in a number of different areas in neuroscience and in neurotechnology. My laboratory in particular works on technologies that can help restore the abilities of people who have lost them, sort of speech or movement. And I think that's where the hope lies, in restoring human function. I think as soon as we start to get into augmentation, that's where I believe a little bit of the hype can come into the equation. We have to be careful not to overreach with the technology that we currently have available and the innovations that are coming out of the lab. But that being said, I'm very excited about the future.
Professor Poo, do you agree with what was said? What advances do you see in your field?
Well, I think there are rapid advances in terms of invasive neuromodulation, decoding the brain signals and monitor the brain signal to use for control of external devices, or conversely, use signals from the outside to manipulate or regulate the brain function. Both areas are already progressing rapidly.
You prone a non-invasive approach to the brain. Why is that?
Yeah, I think in the general populations, it would be nice that we don't go through surgical procedures for many of the brain disorders. For example, brain disorder in sleep. Now, 1/3 of people complain about sleep quality. If we have a non-invasive approach to modulate the brain activity so that people can fall into sleep better and have a deeper sleep, then that would be very useful. I mean, in fact, there are already active research going on using electrical stimulation or sensory stimulation, sound stimulation to change the brain activity, the brain waves, so that they move into the deep sleep waves. And the idea, I think, in the next 5-10 years, we'll see in the market a new closed-loop neuromodulator machines like a ring on your head, so that they could monitor your brain function during the sleep, whether you are into the sleep, toward the sleep, or you are away from sleep, and then use that signal to stimulate the brain to modulate that brain activity, so that it will help you to get into sleep. Conversely, that ring can be a ring for you to help you to maintain the awake state if you want to be awake.
Professor Henderson, you have a more invasive approach. I guess it's complementary. They're both complementary. And why do you have a more invasive approach?
So, two reasons for that. One is when you ask people who are affected by neurological disorders what they want things that are going to help them without them having to really worry about it. So you don't want to have a device that you have to don and doff, that you have to have a caregiver apply, that you need to worry about an external device that needs to be plugged in. The ideal system would be implanted, cosmetically inconspicuous, always on, always available 24 hours a day, 7 days a week. So that's, I believe, that approach, has a lot of promise, and I see it as a mixture of burdens. People with neurological disorders have enough burdens in their life. There's the surgical burden, of course, the risk that you take on undergoing a surgical procedure, which shouldn't ever be underestimated. But the benefits that one gets from that, I think, are can be balanced. And so I think surgical approaches will, for the foreseeable future, be valid and a vital part of both treating neurological disorders. And we'll see in the future whether augmentation actually enters into the picture. I think it's that I come back to your hope or hype question at the very beginning. I think there are many people who hope for augmentation, but we're not there yet. We just don't quite understand enough about the brain to provide that augmentation. We're still working to restore normal function, let alone augment. But we may get there someday.
Well, that will be our closing statement. Thank you very much, both professors. Thank you.